Alright guys, here we go. This is the video lesson for 9-5. This is the first part of two parts, and today we will be dealing with difference of squares. So this is the video lesson for the difference of squares factoring. What you should do now is pause the video and get down the difference of squares kind of rules I have there, or things you need to know about difference of squares. And then unpause and we'll talk about them. Okay, so some rules for difference of squares is that the coefficients are perfect squares, the constants are perfect squares, the powers of the variables are even, and that it is a subtraction problem. Again, it has to be a subtraction problem for difference of perfect squares, subtraction of perfect squares. So I think really the first thing we need to talk about is what is a perfect square. You need to know your perfect squares. Perfect squares are things like 1, 4, 9. Again, 1 is a perfect square because 1 squared is 1. 4 is a perfect square because 2 squared is 4. 9 is a perfect square because 3 squared is 9. So on and so on. I believe that really you should know your perfect squares through 144. So we have 149, then we have 16, because that's 4 squared. We have 25, 36, 49, 64, 81, 100, and then these are the ones that a lot of people don't know real well. 121, because that is 11 squared, and 144, because that's 12 squared. So again, obviously in between there you have 5 squared, 6 squared, 7 squared, so on. But really these are the perfect squares that I really feel like you should know, have memorized, so that you can easily access those. 149, 16, 25, 36, 49, 64, 81, 100, 121, and 144. Okay, so now let's go over here and look at some examples of what perfect squares look like. An example of a perfect square, number 1 here, might be 16 x squared minus 81. Now let's go back up and check our rules here. Is the coefficient a perfect square, or are the coefficients? Coefficients are the numbers in front of the variables. Is 16 a perfect square? Sure it is, so that checks out. The second one is the constant, or are the constants perfect squares? Constants are the numbers with no variables, so is 81 a perfect square? Yes it is, so it checks out. Next rule is are the powers of the variables even? Well, the power of our only variable here is a 2, so yep, powers of the variables are even. And then the last part is it a subtraction problem? Right there you have subtraction, meaning difference. So yep, that checks out. So this here is an example of a difference of squares. Another example might be, let's go with x squared minus 4y squared. In this case, the constant, we actually have a couple of constants. Or not constants, coefficients, sorry. We have a couple of coefficients. In this case, our first coefficient, the number in front of the x squared, is a 1, and the number in front of the y squared is a 4. 1 and 4 are both perfect squares, so we're good there. There are no constants in this case because there are no numbers without variables. And then we check our powers. 2's even, so that's good. And we check to see if it's a subtraction problem. Sure it is. So this is also a difference meaning subtraction, of two perfect squares. And that's what we mean here, difference of two perfect squares. So this one's another example. One final example here, we'll just put down 4. It's a perfect square. X to the 4th minus 9 x to the, let's make that z to the 6th. So again, does everything check out? Sure it does. Again, in this case, both the 4 and the 9 are coefficients, both perfect squares. Both the exponents of the variables are even, and it is a subtraction problem, so we're good to go. That is also an example of a difference of squares. Alright, now we're going to move on and look at some examples that are not difference of squares. Okay, so here are 3 examples that I'm telling you are not difference of squares, and I want you to copy them down and then try to figure out why they're not. So, copy these down, check to see if you can figure out why they're not difference of squares after pausing the video, and then come back and listen to my explanation. So, excuse me, here we go. Number 1. You might say, hey, everything looks like perfect squares. 16 is a perfect square, which you're correct it is. 81 is a perfect square, correct. X is to the 2nd power, which is even. Those are all good, but what's the problem? The problem is right here. That's a sum, not a difference. So it is not a difference of squares because it's not a difference. It's not a subtraction problem. It's an add problem. So it makes this not a difference of squares. Looking at number 2, again, a lot of things look good. What is the one thing that is not good? Right here, 8. 8 is not a perfect square. Eight's not a perfect square, so this can't be a difference of squares if 8's not even a perfect square. And then same problem in number 3. 12 is also not a perfect square. So those are 3 examples there that are not difference of squared problems. Alright, so let's look here at factored form, and let's just take a very easy generic problem here. A squared minus b squared. And we're going to teach you how to factor this. Okay? So, first of all, realize that it is a difference of squares. Again, the coefficients of the numbers are both 1 and 1. 1 is a perfect square, so that's good. The variables have even exponents, so that's good. And it is a difference. So, we do have our difference of squares problem here. If we have a difference of squares, the way you factor this is it's going to turn into 2 binomials. And you take the square root of the first piece. So the square root of 1 is just 1. And the square root of a squared is just a. Or another way to think about this is that you're going to take the square root of the whole number. So the square root of 1 is 1. And then you're going to take half of whatever this exponent is, because taking half of it is taking the square root of it. So, like I said over here, you get 1a in both cases here. And then you will have 1 minus sign and 1 plus sign. It does not matter which way you put it. You can have plus first and minus second, or vice versa. And then the last terms, you do the same thing. Take the square root of that. Square root of the last piece. So square root of 1 is 1. And then you just have a b. And this is the factored form for a squared minus b squared. So let's apply that to a couple problems down here. And I'm going to let you, well, actually I'll go through these first ones with you. So x squared minus 16. So let's factor this one out. You recognize it is a perfect square. It is a difference of squares, DOS, difference of squares. So in the first place here, you take the square root of 1x squared, which is just 1x. Then you have one plus sign, one minus sign, and again it does not matter which way you write it. It could be minus first plus second, doesn't matter. And then you take the square root of the last piece, 16. Square root of 16 is 4. And you're done. X minus 4, x plus 4. Now, why is this the way it factors? And you might notice here, I'm going to erase this and rewrite it. You might notice this original problem here, x squared minus 16. It looks like ax squared, or I'm sorry, it looks like x squared plus bx plus c with this bx missing, or with the middle term gone. And that's exactly what it is. It is that with the middle term gone. And the way you can check that is over here. You could FOIL it. You could say, okay, x times x is x squared. X times 4 is 4x. Negative 4 times x is negative 4x. Negative 4 times positive 4 is negative 16. Oh, forgot my x here. Negative 16. So what happens here is that these two middle terms do cancel out. Positive 4x and negative 4x cancels out, becomes 0. You're left with x squared minus 16. So this factored form here would produce a trinomial, but it's produced in a trinomial where the middle term, the bx, is 0. So we'll back that up, take that away. So that's just how you factor a difference of squared problem. So let's try another one. Number 2, let's try 16x squared minus 81, and see if we can factor this correctly. And again, I already know it's a perfect square, or a difference of squares. I checked all my things. 16x squared is all good. It is a difference. 81 is all good. So, what is the square root of this first piece? What's the square root of 16x squared? Well, it's just 4x. 4x goes in both places. One gets a minus after it, one gets a plus after it. Square root of 81 is 9. Done. And our last example here, x to the 6th minus 4y to the 18th. Change it up a little bit here. So again, go through your check here. Are the coefficients perfect squares? 1 and 4. Yes, they are. They're both perfect squares. Do the variables have exponents that are even numbers? 6 and 18, both even numbers. Perfect. So now, is it a difference? Yes, it is a subtraction problem, so I'm ready to factor. Square root of 1x to the 6th. Well, again, square root of 1 is just 1. And then x to the 6th, the square root of x to the 6th is x to the 3rd, because remember, we're just taking half of what that exponent is. And then square root of 4y to the 18th, we're going to have a plus sign and a minus sign, and we're going to have 2y to the 9th. 2y to the 9th. Done. Alright, very good. So that is the examples of these problems. Next page, we're going to go through some examples, and you're going to be required to do a lot of these on your own. So, moving on. Okay, so here we are. These are the last problems we're going to do. We're going to do these 8. I'd actually like you to do number 1 and 2 on your own. We will do 3 together because there's a little variation on number 3 I want to show. But if you would, pause the video, go ahead and do number 1 and number 2, and then check your answers. Alright, and we're back, and hopefully in number 1 you saw that this was a difference of squares. So you said my answer is going to be m plus 8 and m minus 8, or again vice versa, m minus 8, m plus 8. And in number 2, again, just like on the front page, this is a difference of squares, so it turns into 4y minus 9z and 4y plus 9z. Again, that is taking the square root of both this one and this one. Square root of 16y squared is the 4y. Square root of 81z squared is the 9z. One gets a plus, one gets a minus. Okay, so now let's look at number 3 because it does have a little variation to it. You should first look at this and say, okay, wait, this is not a difference of squares because 3 is not a perfect square. Also, for other reasons, 27 is not a perfect square. Exponent of 3 is not an even number. Exponent of 1 is not an even number. So it's got a lot of things going on that makes it not a difference of squares. So you cannot do difference of squares here. So go back and think about how else I can factor this. And you say, well, first thing I should always look for is to see if I can factor out a GCF. And in this case, you can. The GCF of this problem is 3b. So when I factor out my 3b, I am now left with b squared minus 9. And now what you're going to start learning here, and what I've probably mentioned in class already, is that when you start doing bigger factoring problems, just because you factored the problem once, which I've done right here, does not necessarily mean the problem's done. After you've factored the problem once, you need to look at your leftover pieces, as in the 3b piece and the b squared minus 9 piece, and say, is there anything else I can do to factor it further? Well, obviously there's nothing you can do with this 3b piece. It's just 3b, you're done. But b squared minus 9, you should now recognize this as a difference of squares. So this is going to turn into b plus 3 and b minus 3, or again, vice versa. And then don't forget that you still got to take that 3b down with it because that was the first thing you did to factor it. So there you have it. There's the factored form of number 3. It is 3b times b plus 3 times b minus 3. So kind of a two-step factoring problem there. All right, so let's look at number 4, and I'm actually going to talk about this as we do it together too, because right now you look at 4 and you say, hey, this is a difference of squares, everything's ready to go, and you're correct. 4 is a perfect square, power of 2 is even, and 2,500 is a perfect square. You can check it on your calculator. Square root of 2,500 is 50. So, that's going to turn into 50. So, what you might say here then is, okay, well, this is going to be 2y minus 50 and 2y plus 50. But no, that's not the right answer. And the reason that's not the right answer is you forgot that even though this is a difference of squares, it does not mean that you don't still have to first check for what? You have to first check for GCF. So if you look at this problem closer, you're going to see that really the first thing that should happen here is I need to factor out a 4. You factor out that 4, you have y squared minus 625. Now, what then a lot of you are going to do is you're going to miss the fact that 625 is a perfect square too, because the square root of 625 is 25, so this right here is a difference of squares now, and it breaks down into y minus 25, y plus 25, and again, don't forget that the first thing you did was factor out a 4. So again, don't forget that that first thing you always have to look for when you do these problems or any factoring problems is there a GCF that I can take out first? That's always the first thing you're looking for here. So, next problem, 5. I gave you a hint there. 4 terms means you're going to group factor. So, again, first you're going to look for a GCF. You're going to say all 4 of these terms is something all 4 of them have in common. And right off the bat, I'm seeing a 2. But, again, if I look closer, I'm actually seeing that they all have a 6 in common. So I'm going to start this problem out by factoring out a 6. leaving me with x to the third plus 5x squared minus 4x minus 20. So, took care of my GCF, which again should always be the first thing you look for. But I'm not done because I still have 4 terms here, and 4 terms means I still need to group factor. So put these two in a group, factor those out, and I'll take out an x squared, leaving me with x plus 5. Here I'm going to factor out a negative 4, leaving me with x plus 5. So my group factoring work turns into x squared minus 4 times x plus 5. But don't forget, first thing you did was take out that 6, so there's a 6 sitting out here in front. And now one more step. You still even have one more step. And that one more step is that you got to check all your pieces. And as you check your pieces here, you see this here is a difference of squares. So you need to factor that using your difference of squares method. So let's come over here and write my final answer down. I have the 6 in the front. This x squared minus 4 turns into x plus 2, x minus 2, and then you still have the x plus 5 at the end. So, extremely large, long problem there. What was there? 3 different types of factoring. You took out the GCF, you group factored, and you did a difference of squares all in one problem. So, again, kind of like we were saying before, there's lots to these problems. So, got to know your factoring methods. All right, last 3 problems. This shouldn't be difficult. We're just going to apply the difference of squares method, maybe some other methods, and then end up solving it. Number 6 here. Again, checking to see if these are perfect squares. Some of you guys might be confused here, but yes, obviously 1q squared is a perfect square, and then is 4 over 25 a perfect square? And sure it is. Fractions are perfect squares as long as both the numerator and the denominator are perfect squares. So this is a perfect square, or a difference of squares. So we're going to have q plus something, and q, that's a g, and q minus something. And in this case, our somethings are square root of 4 over 25 is just 2 over 5. So it's like you take the square root of the top number and the square root of the bottom number. Square root of the numerator, square root of the denominator gives you your square root of the fraction. So this simply says equals 0, which means you can now apply the zero product property and say q plus 2/5 equals 0, q minus 2/5 equals 0. You'll subtract 2/5 on one of them and add 2/5 on the other problem. So you end up with number 6 being q equals positive 2/5 and q equals negative 2/5 for your 2 answers. Alright, last 2 problems. 7, this is kind of a review problem. First of all, we recognize we need to subtract 3y on both sides. So I have 48y squared minus 3y equals 0. I'm going to first check for a GCF, which in this case there is one. So I'm going to take out, what is that, 3y leaving me with 16y minus 1 equals 0. Now, be careful here. This 16y minus 1 is not a difference of squares, and why not? Well, it's not a difference of squares because this y has an exponent of 1. 1 is not an even number. So that is not a difference of squares problem that you need to break down farther. You're just simply ready to solve now. 3y equals 0. 16y minus 1 equals 0. And we have, for a final answer here, divide by 3, y equals 0. And over here we add 1. So we get, I'm going to bring it up here a little bit, 16y equals 1. Divide by 16. And y equals 1 over 16. Alright, now, I did that one because that one ended up not having a difference of squares there in the middle. And now this last one is going to have a difference of squares turn up. So let's look at this one, and we're going to say, okay, let's move this over. Let's subtract our 49. Subtract 49a to the third. Subtract 49a to the third. So I have 121a minus 49a to the third equals 0. Going to start out the same way here, taking out the GCF. 121 and 49, I don't feel like there's anything in common there, no, but they both do have an a, so I'm going to take an a away from both of them, leaving me with 121 minus 49 a squared. And now in this case, that is a difference of squares. 121 is a perfect square, 49 is a perfect square, a squared has a exponent that's even. It is a subtraction problem, so this now changes again. I still have that a out in the front, but now this factors into 11 minus 7a and 11 plus 7a equals 0. So you're actually going to end up with 3 answers here. You will have to set all 3 pieces equal to 0 because a is a variable. So we're going to say, okay, a could equal 0. 11 minus 7a could equal 0. Or 11 plus 7a could equal 0. And then again, you just go about solving. Again, obviously the a equals 0 part is already solved. Here you would subtract 11. Negative 7a equals negative 11. Divide by negative 7 and find out that a equals positive 11 sevenths. And then you can go through the work on the other one, but you're going to recognize that the other one ends up being a equals negative 11 sevenths. So you got 3 answers for that problem: 0, 11 sevenths, and negative 11 sevenths. So hopefully those examples helped. Hopefully you watched those and understood those, because you'll be doing lots of problems just like that. So always start with GCF. Check to see if there's a GCF. After that, decide what kind of factoring you need to do. All right, good luck.